Hello everyone, welcome back to my channel. Today is day 10 of our 100 days of DevOps, and today is a very very good day. We've hit the 10 days milestone, and I'm so happy for where we've come from, and I'm also excited as where we are going to with this so far. And today we are going to continue in our networking fundamentals. Today we'll be getting introduced to some new concepts, and we'll also be doing some things in the terminal. I know for the past 2 days we've basically been trying to understand some basic networking concepts like IP addresses, subnets, OSI model, and the likes. And if you've not checked out my previous videos, I would advise that you check out the previous videos starting from day 1, because it's good not to miss anything. So start from day 1, and then you can take it up to day 10, which is today. So because I'm sure that at the time you're seeing this, of course it would have been uploaded, so you can start from day 1, and I'm very sure you're going to learn 1 or 2 things in this first 10 days. So like I said earlier, but before I go into that, I also just want to use the chance to just mention the need to subscribe and turn on your notification bells for my channel, because when you turn on the notification bell, you get notified anytime I post a new video or a new content, which will definitely be helpful to you in one way or the other. You can also do well to share this channel with anyone who's interested in learning DevOps, in learning cloud computing and tech in general, because basically in tech.sam, this is all we cover, or this is what we cover for now: DevOps, cloud, and tech in general. So now that we have that out of the way, let's go into the business of the day. So we've talked about IP addresses, we've talked about subnet masks, CIDR, OSI model, TCP/IP. Today I'm going to be covering 3 fundamental concepts in networking, which is routing, default gateways, and NAT. So those are what we're going to be covering today, and we'll start with routing. So what do we understand by routing? So the definition I have here is routing is the core of how devices communicate beyond their local network. Without routing, your computer could talk to devices on the same subnet, but not beyond. Routers act like postal systems. They deliver your data to other network. Basically, what this is trying to say is that, say, for example, you have a computer and you're trying to talk to let's say Google server or Facebook server over the internet. So basically, routing actually defines how your request gets to that particular server. In the second video, which is yesterday, we talked about the OSI model, how data is sent from the application layer down to the physical layer. Basically, I said it's what happens under the hood when you actually input, let's say, a website, let's say, for example, facebook.com. I ran us down the different levels through which data moves from your computer down to your server. That's to make a request. And then same way the data moves from the server back to your computer, which is a response to the request. So it's just take it as let's say a GPS. So when you're going to a particular location, you bring out your what do you call it, map on your phone, and then you put your current location, you put your destination, the location of where you're going to, and then your GPS shows you a road map, calculating the best route or the shortest route to help you get to where you want to get to. So basically, it's just concept is the same thing. So for example, now what we see on the screen now is that my laptop, my system on the top left is trying to communicate over the web to maybe Facebook or Google server on the bottom right. So what does it do? Like in definition, routers is actually what helps us define the path that data takes to get to a particular destination. And I also mentioned that in the video of yesterday, that's day 9, and that's why it's very, very important that you don't skip any of these videos, because every video that we do is layered on what we've learned the previous. So I'm going to be making a lot of reference to what we've learned before. So if you decide to skip any video, you might be doing yourself a disfavor, or you might be missing out on a whole lot. You get, but to grab the whole full package and the concepts, it's very, very good to follow these videos one after the other and not just skip to this particular one. So this system or this laptop tries to connect through different routers. So there are different routers for it to that will take the request. So now, how does it define the best way to get? So it connects to the first router. The router determines which router is also the closest or the best for it to connect to. So it connects to the next one, and then it connects to the next one, and then the next one, and the next one, and then the next, and then it finally hits your either Facebook server or your Google server. And basically, this is how request is made, or this is how your request or traffic is moved, or data is moved from your computer down to the maybe Facebook server or Google server. This is basically what routing is all about. It's just basically trying to pick the best paths that your data can travel, the best shortest path that your data can travel to get to your destination and back in terms of receiving requests. So basically, that's the whole concept of routing. So you might be wondering, how does this occur? This occurs, you can check your, let's say, you can check your router, or you can there's a command in Linux. Let's go to our terminal. Let's do to check the route through which your data leaves your computer. You can use the command IP route. So IP route will show you you can see default via this. So this is the IP address, or this is the route through which your computer sends, or your virtual machine sends data out of out to the internet. That's the route it takes. So this is actually I'm still going to come back to this, because I'll still make reference to this when we're talking about default gateways and the likes. But before all of this, I want to paint a quick scenario for you. So let me go back to my slide. So okay, we've talked about routing. So now let's imagine now that this is a network. Let's say this is network A and this is network B, and then they're trying to communicate with each other. So now we've established the fact that VMs or computers within the same network, they communicate with, okay, let me not say we've established the fact, let me just say it now. Computers within the same network, they communicate, they don't use their IP addresses to communicate, they communicate using their MAC addresses. So MAC address is like you are showing the physical, is an address that is tied to a particular device. So I also mentioned this, I think, in the second video or in the first video, that MAC addresses do not change. IP addresses change, but MAC addresses do not change because it is linked or registered to one particular device. So since they are on the same local area network, they don't need IP address, because IP address, like the name sounds, internet protocol, is only needed when there's unexpected communication over the internet. That is when an IP address comes into play. But if they're on the same network, of course, the MAC address is very well enough for them to communicate. So let me move this. So yeah, okay, so we have this diagram here. So let's assume that the IP address of this is 192.168.0 dot dot 0 dot 0 dot 0 dot 0 slash 24. So when you see this particular IP address, now just a quick recap. If you see 192.168.0.0 slash 24, how many IP addresses are available? I'm going to give you a second to guess. I really hope you guessed right. Yes. If you guessed 256 IP addresses, then you are very much correct. So this means that in this particular network, there are 256 IP addresses available. So now let's call this one. Let's call this one let's call this one 10.3.0.0 slash 24. So also this means that there are 256 IP addresses available here. So now let's imagine that these let's give this one dot 2 dot 2. Let's give this particular one dot 3, and let's give the third one dot 4. So this, if you notice, the first three octets are the same. 192.168.0, they are the same. It means that they are on the same network. Then the last is what differs. One is 2, one is 3, one is 4. So now you would wonder, why did I not give anyone .1? The reason is because .1 is usually used as something that I call, or something that we call, gateway. So with that, I'm going to explain the concept of gateway. So what do we call a default gateway? Just like the name sounds. Let's say in a building now, you have you're in a 3-bedroom flat, and if you want to go into the rooms in the building, you can just easily go into the rooms without any hassle or anything. Just knock on the door, enter. But let's say you want to go and get something at a grocery store or at a mall outside. You pass the gate of the compound, or you pass the gate of the building. That is exactly what gateway means. It just gateway is like, the default gateway is what enables computers on one network to talk to computers on other networks. So it's the route through which data passes from one network to another network. So basically, that is what gateway does. Is the pathway through which, if you want to talk to any other network over the internet, you must pass through the gateway. So without a configured gateway, systems cannot actually talk to systems on other networks rather. So that explains gateway. So basically, let's call this in C. Let's call this network A. Let's call this network A, and let's call this network B. Let's call this network B, and then let's call this network C. So if any system on network A wants to connect to any system on network B, it has to go through the gateway. So, and this gateway now connects to a router, which now sends a message back to the switch. This device in the middle is called the switch. The switch is connected to the router. So the router is connected to the switch, vice versa. So it comes back to the switch, and then sends the information to any system on this particular network, and then the system responds. If there's need for a response, it responds back through this route. So now you might want to ask a question: how do the system, or how do each network know which route to take? And that's where the routing table comes into play. So the routing table is like a table, like a set of instruction that shows you all the information. Like, let's say, for example, the type of routing, the network, destination network that is going to, the interface that it's going to use, and the gateway. So those are the components of a routing table. So let's say, okay, before I mentioned interface, what is an interface? Basically, a network interface is what helps, the whole connection, like the Ethernet network, the cable and everything. That's what we call a network interface. If your system does not have a network interface, your system will not be able to connect to the internet at all. Like, your system will not have network at all. Of recent, I had an issue where my laptop could not locate or see my router, and I had to, after troubleshooting for a while, I discovered that the issue had to do with the network interface card. So, and then until when I was able to fix it, that was when my laptop could now connect to my router. So basically, once there's an issue with your network interface, once there's no network interface, you basically do not have access to any form of internet. You can't connect over the router or over the Wi-Fi. So that's how important, the network interface are. So, and if you're familiar with Linux, you would see things like let's call this ETH1. You'll see things like this, ETH or ENS or something like this. So now what happens in this case is that your router there will be two network interfaces connected on either sides of the router. So what happens is that the router updates its table. So since these two switches are connected to the router, this is a direct connection. This is a direct connection. So that is one type of how will I call it now? Routing. That's one type of routing. So there's a direct connection routing. So because they are both connected to the router, the two switches are directly connected to a router. So this is a direct connection. So in this case, the router updates the addresses of the two interfaces. This is also a direct connection. So it updates the two, and this is so it puts this one as ETH1 and put this one as ETH2, and then it includes the gateway through which this network is passing through. So basically, this is what is usually updated on your routing table. So let me include the gateway of this other one. So if there's any part you do not understand, you can always drop your questions in the comment section, or you can take your time to watch the video. And when you watch the video over time and it's still not clear to you, you can drop your questions in the comment section. I will be so happy to answer them. So basically, this is what happens. This is what happens in this kind of scenario. It updates the route table like this. This is just a typical view or typical example of what your route table will look like. This is the components of your route table. Now, this too has direct connection. So now, apart from direct connection, there is also two other types of routing. We have the static routing and we have the dynamic routing. I'm going to explain the static routing and dynamic routing now. So now, these two, network A and network B, are connected together to a router. the router, this is done with direct connection. The router has updated the routing table. So now, let's say, let me give this an IP address. Let me give this an IP address. Let's say this is, let's change this to 172. So 172. So let's say, this computer 192.168.0.3 wants to connect to, let's say this particular computer, this one here, which is 172.168.0.3. What happens is that it sends a request. It sends a request through the switch to the router, but in the routing table, there's no how will I say it? There's no record of this particular VM. So what happens is that the router drops the message. So now let's say now this particular network is connected to a different router. What will happen is that this router will connect to this router. Like I said in the first illustration I showed you, different routers are connecting to each other. So let's say now this one's now, it treats it as two different networks. Even though they are both routers, it treats this scenario as two different networks. So let's give it a network of 125.0.0.24. So let's say, yeah, this is basically this is the network that these two routers are on, that they're using to connect to each other. So what happens is that this particular router connects to this particular router also, and then updates. Okay, sorry, I would rephrase that. This particular router connects to this, but it still cannot send message until you go and update it. As the administrator, you have to go and update it yourself. So what you do is that you just update. You log into the router. And you create a static entry on the routing table. So now, which network do you want to communicate with? You want to communicate with this particular network. This is what you put there. Let's give it let's just assume that this is ETH maybe 3. So and then this, now we now use this as the gateway. So it passes. So now when this one sends a traffic down to this router, the router is able to talk to this, and this is able to now talk to this. So basically this is what happens. So it might be really complex or really complicated, but it's actually not that complicated. It's something that is, if you understand it well, one network or one computer on a network cannot communicate to a computer on another network until there's a router that is connected to it. That's just the concept. That is, if there's something I need you to take home today, this is basically what I just need you to take home. Two computers on different network cannot communicate together unless there's a router that is involved. So that's the whole concept. And then a routing table is like a table where all the information about the route that you will take to get to a particular place is stored, so that whenever you want to send traffic, it checks through the routing table, and then it routes your traffic to the appropriate place and gives you response if possible. So now in this case, this is a one-way thing. 192.168.0.3 is able to send traffic to 172.168.0.3, but this is a one-way traffic. For this to be able to send traffic back to this, you need to update. Now, the table that I've been updating is the table for this particular router, not this particular router. So now we need to go and update this particular router's table in a static way, so that it can be able to talk to this, so that there can be free flow of data to and fro. So basically, you just have to, for this particular, for network A and network B, they can talk together because they are directly connected to the router. So they don't need any extra configuration. But because there are two routers between network A and network B, you need to update both routers' routing table for them to be able to communicate. So that's basically about routing and about gateways. Like I already explained, gateways is the like a path through which information travels from one network to another network. So information or data cannot leave a particular network if there is no gateway. So let's go back to our terminal now. So for practical purposes, I created another server. I created a Red Hat server. So this is my Red Hat server. So it's quite different from the Ubuntu server in the sense that I set up the desktop version for this particular server, while I just used the server version for my Ubuntu. So you can try that out also. So this is my Red Hat server, and I've connected to it via SSH here. So if I do, let me clear this. If I do host name, let me do IP-ADDR, you can see that my IP address is 192.168.199.136. If I come here and I do IP-ADDR, you'll see that my IP address is 192.168.199.138. So if you notice that the first three octets is 192.168.199, check it. It's the same thing. So basically, this is an indication that both virtual machines are on the same network, and that's because they are on my laptop. It is connected to a router, so it's the same network. It's just the last octet that is different. This one has 136, while the other has 138. So now I'm going to let me run IP route again. I said I was going to come back here. So now I want to explain gateways. So how do you know the gateway through which your virtual machine communicates? So now there's something called the default gateway. This default gateway is a way of saying when the router checks its IP table. Okay, let me take it back a bit. This particular one here, this second one that has 192.168.0.2, this particular one is used to communicate with virtual machines on the same network. That's why you can see that it has 0/24. So as long as there is a virtual machine on this network, it doesn't need any gateway. If I go back to my slide, I explained that once they're on the same network, they don't need to communicate outside. So because of that, they're not really like using that gateway for anything. They're not using it for anything because there's an internal communication. They communicate by using their MAC address. So once the MAC address is in play, they're not using their IP address. So, and we know the format of an IP address, 192.168.0. This is, so anything that involves things like this, if there's a communication on the same network, we are not necessarily using it. We just use the MAC address to communicate. So while if you're communicating outside, that is when this particular one comes into play. This is default. You can see that it is two rows, this one and this one. But this 192.168.199.2 is repeated here. So it has used this one as the default gateway. So let's check my second VM. Let's check the IP route. Let's type IP route. So now when you type IP route, you can see that it's the same thing, and they are both the same. And you wonder why are they the same? The logical or the most simple reason is because they are on the same network. Because if you come here now, there's this, let's just say this is the default gateway. Since they're on the same network, this particular VM, this particular VM here cannot have a different gateway from this other one. They will all have the same, gateway IP addresses. They will all have the same thing because they are connected to the same network. So I'm going to do something now. There's a command that you use to check or to reach out to a website or any website or IP addresses to confirm if they're actually on, and that's the ping command. The ping command can be used to, it's like you're sending a message to an IP address and you're like, okay, are you online or are you available? So, and then you get a response. So let's ping google.com. Let's ping Facebook. Facebook.com. And okay. So when you get such a response, you can see that once you get a response like this, it means that you are able that's the platform or the IP address that you're trying to reach is reachable. So you can see Facebook's website. Let me stop this. So you can see Facebook's IP address. So it just shows that 64 bytes was sent to Facebook. This is the Facebook IP address, and this is ICMP, which is I think Internet Control Message Protocol. I think that's the name. It's just this is total. I think this is total time or something like that. You can check more on this. But I know that this has to do with the timing of, and then you can see the time here, 71.9 milliseconds. So basically, this just shows that it is reachable. Let me clear this. Let me ping my second IP address. Oh. Let me ping my second IP address. And paste it here. So you can see that there is a difference. There's the details from Facebook was longer than this one. So you can see 64 bytes from, this is my IP address, the same ICMP and the time. So now, we have established something now. Both facebook.com and my second VM's IP address are reachable. Now, to trace the path through which your VM has used to reach a particular another server, there's a command called traceroute. There's a command called traceroute. So you use traceroute, then you type the name of the IP address. So let's first try traceroute with our IP address. So when I press enter, it only shows that it reached out to it directly. You can see it there. It reached out to it directly. So there was no middleman. There was no intermediate. Connection or any, jumping through hoops just to get to this particular VM. That's because the virtual machines are on the same network. But let me do traceroute to facebook.com because we already established that both facebook.com and my other VM are actually reachable. So let's do traceroute. Let's see what will happen. So it does first one. You can see that this 192.168.199.2 is what is the default gateway that we showed earlier. So now it will first, like I said, it will first reach the default gateway. In this particular case, it went directly because they are on the same network. But because what happened was that when it checked facebook.com, it checked the route table to see if facebook.com is on the same network. Obviously, facebook.com is not on the same network because they have entirely different IP address. So what happens? It has to, send a message to the router just to get to Facebook. And for you to be able to reach the router, you need your gateway. So that's why the first thing that it's showing is the gateway. Normally, it's supposed to show other IP addresses, but I think there's actually an issue which I need to look into and check. That's why we're not seeing other IP addresses. On a normal situation, you will be seeing the different routers that this VM is hitting before it gets to facebook.com. You can use this when you want to troubleshoot and see why you're not able to reach a particular maybe if you're using maybe a particular database or a particular platform, a particular application, a particular website. So these are some tools that can come in handy. You can use them to troubleshoot. You ping them, you check your routing table, you check your firewall and all of that. We'll still cover all that later. We also need to consider DNS. So I think we might look into DNS maybe tomorrow or next. So those are the things that you need to actually consider. So basically what we've covered so far, we've covered what routing is, that's IP route. We've established the fact that devices on the same network can communicate together using the MAC address. Why, if they want to communicate outside, they use they have to go through the gateway. So, and then we've looked at the concept of routing tables and what is actually inside the routing tables, different type of routing tables. So I forgot to mention, I said there's static and there's dynamic. In dynamic routing, what happens is that each router just they are in the same. Each router just dynamically updates each other's routing table. So this one picks the details and then updates here. This one picks the details and updates, and this is done through dynamic routing protocol. There's a particular protocol. This is like a deep dive. If you really want to, go into networking core, then you can look into this. There's a protocol like I think RIP and then some other protocols here. I'm not going to discuss that now because that is deep networking fundamental. So the direct connection, the static connection is enough for now. But if let's say you want to go into networking, or networking is something that intrigues you, you can also read up more. If you have any other thing that you can suggest, or maybe if I missed anything or I said anything wrong, because of course I can't know it all. So if there's any additions, you can always drop it in the comment. I'll read them, I'll respond and all of that. So we've covered the concept of routing, we've covered the concept of gateway. So we understand how routing and gateway, the purpose of gateway and all of that. Now the last thing I'm going to talk about is NAT. It basically means network address translation. And what does it do? It basically, before now, let's go back to the IPv4 and IPv6. On today is day 10. On day 8 where we started this networking fundamentals, the first thing I talked about is IP addresses. And I established the fact that we have two versions of IP address. We have the IPv4 and we have the IPv6. The IPv6 is relatively newer than the IPv4. So in an IPv4 address, because like I also said, the most common type of IP address that we have now is IPv4, and this is what we use most of the time. So now there is limitations of IPv4 in the sense that total number of IP addresses available in IPv4 is about 4.6 billion IP addresses. And I'm not exactly sure of the total population of the world. I want to believe that the total population of the world is more than 4.6 billion. So I feel that the people that were setting up the IPv4, they probably did not have it in mind that the population was maybe going to need more than 4.6 billion IP addresses. So in that way, because of that, there is a constraint of IP addresses. So what NAT comes to do is that when you're using a private IP address, you can have like you can use any type of private IP address. But if you're using public IP address, it's 4.6 billion. So what it does is that to create accommodation for different type of IP addresses, it converts your private IP address to a public IP address, and it converts your public IP address back to your private IP addresses. So that way you can have so many private IP address, and then you just, when you want to send a request, is not convert it. Everything is done in your router. So it converts that private IP address to a public IP address that is used to communicate to the outside world. If you're familiar with AWS or if you're familiar with Azure, you would notice, especially I've worked more with AWS, you would see when you create an EC2 instance, which is a virtual machine, you would see that it has a private IP address. A private IP address. So now, when you now want to, communicate to the outside world, you need to set up some things like your internet gateway and all that, and then you just set up everything. You check your table, your routing table. So, and when you request for a public IP address, you are going to now be given a different IP address, which will now be used to access the internet. So basically, this is what NAT does. I don't know if I was able to do justice to that particular explanation. So what in a summary is, what NAT does is translating or converting public IP addresses to private IP address, and vice versa. It converts private IP address to public IP address, in the sense that when a data is coming from a public source, when it comes in, it changes the IP address from the public IP address that was used to send the information down to a private IP address and send it to the designated virtual machine or designated location. So with that's basically what I wanted to cover today: routing, default gateway, NAT, and I was able to show you at least 3 commands. That's the ping that is used to check the availability of a particular IP address. Then we use the IP route to check our routing table for our default gateway, which is used to communicate outside. And also we use the traceroute command. Traceroute command is just a way to see how the steps or the routers in which your machine was, in which your data passed through to get to a particular location, let's say the Facebook server or the Google server. So I believe I've been able to at least impact you in one way or the other. So we're going to see again tomorrow. So till then, cheers.